All right, time for another draftphysics.com, debatephysics.com. Did I say draft physics? Yeah. Anyway, video presentation. All right, still on the same subject, I guess, because it's so obvious in a sense. I mean, it's a basic function of physics, this idea of energy. And the fact that there does exist an energy duality, there's no doubt about it. So Archimedes, thousands of years ago, did a bunch of stuff figuring out how levers and screws and different things worked mechanically. And all of those rules worked up to whatever, 1668 or whatever the right number is for Leibniz and Huygens. Huygens, I think, was first. To say something else is going on, underlying this basic obvious mechanics where it just seems to be about something being heavy, giving it some energy component, and then something like how fast is the heavy thing moving, and they could figure out that, yeah, that's basically all you need to know. How heavy is it, and how fast is it moving, and you know all you need to know. And they said, no, you don't. There's something hidden. Okay, even though they'd done all these kind of experiments over and over again, found out these clear proportional rules, no, somehow it's all broken. And rather substantially broken in the sense that if you believe in kinetic energy, silly things start coming out of your mouth, like it takes 25 times the fuel to spin something 5 times as fast. No, it doesn't. And that something spinning 5 times as fast will do 25 times the work, which, no, it won't. Anyway, it's just not true. It's just silly. But that's what they're going to defend because they have to, because they've decided they've chosen this modern advancement in science. Okay, and it's quirky neutrino dark matter bullshit, nonsense, silly. Anyway, so I'm stuck in this position of saying, gee, it's just so, this is so obvious. So if you can't get this one, you're not going to get any of the other ideas where, yes, gravity is actually an active system of force. It's not made out of a bent geodesic. It's made out of real something. Real something has to travel. The gravity has to travel through distance over time. It takes time for gravity waves to get here. Your own science concedes. So why is the bent geodesic slow? Why is it moving slowly? Anyway, it's all just so irritating. All right. So anyway, I found this video. I mean, I'm just trying to find. Unfortunately, I'm trying to research all of the people who were reasonable and defended the previous well-established science against the new modern crapola. So there is this 150 years of argument, and unfortunately, you can't find any of it. So. That's in the right language anyway. It was all done in German and French and Latin and some other crap. And so it's really, if you can find somebody's submitted paper, it's always in the wrong frickin' language. So anyway, which is, just be nice to know exactly what people argued, but no, can't find it. And obviously what was highlighted was the Deschardelet nonsense. So, she dented Clay, Gransfeld, whatever, a guy who believed in perpetual energy, did some Clay experiments. Very good experiments. I mean, it's a reasonable thing to do, drop stuff and see what happens. It's just obviously if you drop round surfaces and only dent surfaces, that it not penetrate past halfway on the surface, then you can understand theoretically you're not going to get a reasonable answer because basically the shape of the object changes with velocity. So the faster it's going, the more flat the surface, the slower it's going, the more flat the surface is. The faster it's going, the further it's going to penetrate, the more pointed the surface is. That is, the more it pushes sideways rather than down. So yes, you're not going to get a good measure of real energy, just like you can't measure energy by putting a pointy arrow on a stick and saying the pointy one goes in further and so therefore it has more energy. No, it's an obvious advantage created by the way you're applying the energy. So it's not an example of more energy. I mean, an argument that simple everybody should get. No physicist should be fooled if I do an experiment with a pointy arrow and a dull arrow and then say, look, the pointy one went further and it has more energy. Is a physicist going to fall for that? You know, should they fall for that? Should it be acceptable to have a physicist fall for that? Yeah, these are reasonable questions to ask. So, anyway, so Steve Mould has argued that levers don't obey the law of the lever, that somehow the thing moving more distance, that is at a higher velocity, do obey kinetic energy and not momentum. So levers don't conserve momentum, is his argument, and they do conserve kinetic energy. So you don't need to put a one mass twice the distance. You only need to put a one mass 1.4 the distance because then it'll have the same kinetic energy in its motion. Clearly won't work. Okay, clearly never has worked. It's not how levers work, and I have to make these arguments. So anyway, I did find this video, so I'll play it real quick. I don't think we need any volume. Nothing's really said here. It's terrible that somebody would subject his grandchild, no doubt, to a potential catastrophe. Now, you know, in a lot of ways, this can't go wrong in a way that could do anything but hurt his toes. But, you know, you never know. There's that 1 in a million chance where the board splits just the right way, the top end flies up and knocks his little head off. But whatever. I mean, it would be my impulse never to put a child in useless risk. This is useless. I mean, to point out how easy it is to do, he's just letting, say, a child can do it. And it's just not the kind of thing, it's not the kind of mechanism you expose a kid to. It's just really, really stupid. So, you know, people just annoy the hell out of me. I didn't want to do that. Anyway, alright, so let's play it. So he's got gigantic rocks suspended, less distance. Who knows? You know, it's not probably 2 to 1, and then he's got some buckets of rocks on the other side balancing. So now all of gravity's influence is gone, and now you basically have 2 buoyant masses. And the idea is yeah, you can push the buoyant masses around really easily because you're not fighting the force of gravity anymore. The heavy, gigantic mass is not collecting a whole bunch of force opposing you, so you can slide them around, and they seem, okay, a lot less heavy, okay, but they're really the same mass. It would be this way in space, for example, if you were out of gravity, and you don't have to fight some kind of force to give something momentum. So it just kind of shows that slow speeds for big objects are not that hard to do. That you can, I remember when I was a kid, okay, I went deep sea fishing a few times, and the guy we'd go with had his, his own little boat, and it was just a guy, and so you'd push his boat, to get it in the right direction so he can, turn the motor on and make it go off the pier, and you could just push it. It's a big boat, and you could just kind of push it, come from the shore, and it would go where you want it to go because, it's floating. All right. See, the other thing annoying about this is they kind of like set it up so the kid would have this task and they'd film it, and so he kind of totally failed, and so now he's just being basic, oh look, I'm a failure, so it's just more psycho crap you're imposing on some kid. I mean, obliging the kid to know what the fuck this is all about and what he's supposed to be doing, it's just it's just stupid. So obviously the pivot here sucks. So that's a whole, you can almost see this whole thing could collapse. But anyway, in the sense that he didn't put some kind of device to create a better fulcrum. So you do have a lot of wood rubbing against wood. So, it makes it a little stiffer than it would have been if he figured out putting a rock on there or something smaller that would create a better pivot. It would indent into the beam a little, and, it'd give you a nice, the smaller the fulcrum, the less friction, frankly. Now, I have to give him credit. He did put this chain around this rock in such a way that it's well balanced. Okay, but anyway. Oh, look. See, the bottom of the thing is tilting. Get the kid out of there. Can you see that? That is just, I didn't see that before, but oh man, can you see this gigantic tilt? Oh, really? Look, that's really stupid. Look at this. The whole thing is going to tip over. Oh, shit. What people do to kids. Just, shit. Shit. You get the kid out of there. Get the kid. Oh, okay. So finally he did push him away a little bit. So his whole thing is tipped. And so now he's got to try to get up there. Okay. So his whole fulcrum was going to fail. But look, the idea is clearly it works. Okay. Clearly leverage works. So now he's made his job a little tougher because now to lift that rock, now he's lessening the amount of weight on the other side, which doesn't really help him much. So he's going to pretend it's okay, even though they failed. They're just going to pretend, job well done. Okay, not so well done. Anyway, all right. So I just thought I'd throw it in there. You can't find too many of these examples, and obviously we don't know the masses of anything here, and all that kind of crap, but it just demonstrates what the lever's doing. Is it's saying this, whatever's on this side ends up equaling what's on that side, and that always obeys momentum. So it doesn't obey kinetic energy. You can't have a one mass 4 distances out, and a 4 mass 1 distance on the other side, and it will balance perfectly, telling you the two things are applying the same energy, that it's the same amount of force manipulating one as the other, and the manipulation is again by gravity jiggling them. Gravity's constantly jiggling them and testing them, and it's saying that one mass moving 4 times the distance is the same as the 4 mass moving 1 unit of distance. It's telling you the momentums are equal. There's no difference. There's no inertia problem. One of them isn't harder to push. One of them isn't any of that crap, because obviously one of them's going 1/4 the velocity, 1/4 of the velocity. So it works perfectly. Again, Archimedes was perfectly reasonable to sit there and diagram this logic and say, yeah, just look, twice the distance really works. And they're saying, no, it doesn't work. So I'm just saying, you think that's good physics. So they should make videos that get millions of views saying the law of the lever doesn't work, and levers don't measure momentum. They measure kinetic energy, when they clearly don't. All right, so moving on to the next bit of craps. All right, so here's an old Julius Sumner Miller, an eccentric fellow, let's just say, physicist. They are a little bit, they come in weird categories, don't they? Anyway, so this one's called Energy and Momentum, which you might as well not bother trying to do it in any other way but say, look, we have 2 ridiculously different definitions of the same exact thing. Isn't physics idiotic? And that's all this show should be about. So he's just basically talking about this is just the 1 mass against the 2 mass. Well, the 2 mass against the 1 mass. The 1 mass against the 1/2 mass, however you want to describe it. and the collision. And the idea is that the half mass going twice the velocity somehow has twice the energy. Now, he's not going to demonstrate it by allowing the two cars to actually hit each other. So, yes, that would show which one had more energy. So that never happens. And he's just going to do this convoluted mush about somehow, well, one's accelerating and twice the distance it traveled. Well, of course it went twice the distance. It's going twice the speed, so of course it went twice the distance. How does that make it have twice the energy? It's half the mass. It's half the momentum. In the mass percentage. So it's clearly got no advantage because it's light and small. I mean, it's just silly. So we'll just play this part, and then I'll play the end part where. So the video really doesn't say any. It doesn't do any experiments that really just demonstrate you have to make a choice between kinetic energy and momentum. So he avoids levers and things like that.
Now we also saw on another occasion that the little car...
So he doesn't let them hit, right? So if you just let them hit, and everybody could just say, well, okay, yeah, they didn't go anywhere, so it means they both had the same energy, right? Because they didn't go anywhere. They crashed up and did things, but the whole crash didn't go in one direction because one of them didn't have more power or ability to do work. They have the same ability to do work. They would hurt something. If I put something in the middle, they would hurt it just as much going this way as they hurt it going this way. No doubt about it.
Wired the greater velocity, and the bigger car, the lesser velocity.
So this is the obvious, momentum diagram that just works so well visually. You can just do it this way. You just say, yeah, you got a bigger M. You just make the M proportionally to its size and the V proportional to its size. And just say, look, the sizes have to match. The total amount of ink on the paper has to match. I mean, you can make it that simple. And it works so well. And all of you lunatics are for some dopey religious kooky reason are saying we must Holy Ghost that velocity. We must put a square on it somehow for some dopey reason. So then we can believe that it takes 25 times the fuel to go 5 times as fast. That's what they're saying to you. It takes 25 times the fuel to go 5 times as fast. Have you experienced that anywhere in your life ever? Of course you haven't.
And we call the product of M and V the momentum. And it is not unreasonable now to say that because the accelerations are inversely as the masses...
Well, so of course, if you're going to have the inverse velocities, you have to have inverse accelerations. Oh, gee. Like acceleration is anything other than just adding or subtracting a velocity. There's no such thing as acceleration outside of the context of merely adding or subtracting velocity. Velocity is the thing. That's the substance you're adding or subtracting. Acceleration is not some special new force.
The velocities are so... And therefore, the momentum of the little car is equal to the momentum of the big car.
Which will be demonstrated if I allow the two cars to hit each other. But he won't let that happen. Oh, hilarious. They're crappy little shit cars. You think, oh, well, yeah, they can't do much damage to each other.
So their momenta are equal. But now watch.
Now watch. I won't let them hit each other. Yeah, because that would demonstrate something. We don't want to demonstrate anything.
Is it not true that the smaller car went the greater distance?
Duh. Yes, it has twice the distance. Twice. It went twice the distance. It has half the mass. Oh, there you go. Yeah. Half plus 2 equals 1. Oh, shit.
That is... If I let them come from a place of rest and meet, they would meet somewhere in here. This is the distance the big car would go, and this is the distance the little car would go.
Yes.
So the little car goes...
1/3, 2/3. There you go. It all adds up. So what? It's 1/2 the mass.
Goes the greater distance. S, little s. And now I define for you what is meant by work or energy in physics.
Okay, so physics is specially special, okay? And so in physics, it means something specially special. When no, it doesn't, okay? The definition of work is actually accomplishing something, okay? But the fact is motion is motion. So if you're sawing a piece of wood and you're making the wood hot and the saw hot, you're doing work on the saw and the wood. Okay, that is something other than cutting the wood. And it's just a fact. It's still work. It'd be silly to call it something else because you could be trying to make it hot. You could be trying to make a fire, right? So if I was sawing on the wood to try to make a fire, then somehow I'm doing work on the wood to try to make a fire. But if I create heat in some other circumstance, and somehow that's not work. I mean, it's a nonsense. The whole invention of the concept of work is silly. It's always a transfer of energy. Anytime you move something, it's going to hit something else in the universe and move it. Fact. So there's no conversation. You're just saying, did I transfer my energy? And you're just saying, where did I transfer it? Did I transfer it to something's motion? Did I break its fender? Where did my energy go? Denting a fender is a good example of the weirdness of it, just in the sense that you dent the fender and that looks like you did work, but the energy's still moving. It's been now converted into heat when you dented that. So the denting doesn't mean anything. The real work is the fact that got converted into heat. Denting makes heat.
The product of a force and a distance. The product of a force and a distance.
So energy is always working. It always continues to work. So the energy you throw in a direction, right? If I push the atmosphere and I push stuff, it doesn't ever stop until it leaves going into space, or it heats some water and evaporates some water, and then that goes into a cloud, and it never stops working. Ever. So, the concept of work is kind of ridiculous because nothing ever stops. And what we're really just talking about is, can we keep the work from turning into discrete and spread out heat? Because we can't do much with. So we need the heat, we need the work to stay concentrated in a direction for it to do anything we want to accomplish. And as soon as it starts spreading, and going all kinds of directions, then we don't have any use for it.
So, the same force acts on both cars, but for the big car, the distance is a little one.
So he's saying it's the same force that's acting on them, but obviously the idea of how you're applying the force is over that distance. So because of the fact that you're accelerating 1 to twice the speed, so it needs twice the distance to acquire the same impact force of twice the speed and half the mass. Saying gravity's the same force applied to everybody is just not getting the point, because it's about how much of the force you're collecting. So a big sail in the wind collects a lot of wind energy. A small sail collects a small amount of wind energy. So it's kind of silly to say, okay, it's the same force. Well, it's not really the same force because one object's going to collect so much more of it.
And for the little car, the distance is a big one. And these products are not equal. So we learn.
So we know that the velocities aren't equal. We know the accelerations aren't equal. We know, okay, yeah, the distance isn't equal. So what? Why does that mean I have to square the velocity? Why does that mean that moving the half mass twice the speed means I somehow created free energy of some kind that you won't demonstrate to exist in any form whatsoever? You'll never show me 5 times the velocity doing 25 times the work. They'll do 5 times the work. 5 times is a lot, right? 5 times is a lot. Their theory is it's 25 times, and they have absolutely no experimental evidence. So 0 experimental evidence.
And this astonishing thing, that although the forces are the same, the accelerations are inversely as the masses.
So that doesn't mean it's still, that's the whole point. Yes, as the mass goes down, velocity goes up. Okay, we got all that. You're just using a different word for velocity. You're saying calling velocity distance, calling velocity acceleration, calling velocity something else, but it's just a velocity, frankly. We see it's just a velocity. You can call it something else, but it's just a velocity.
The distances are inversely as the masses.
So is the velocity.
The momenta are equal, but the energies are not.
Says you with no evidence. You wouldn't let the stupid cars hit each other. Let the cars hit each other and show us the one doing more work. Show us twice as much work being done by the lighter car. And it won't be able to show it because it doesn't ever happen in this universe. Ever.
Very important idea.
Very stupid. Yeah, let's keep going.
Now this business of energy, beautifully demonstrated as follows. Look what we have here.
So again, it has twice the distance in it. So is there any logic to this nonsense? That the ball somehow has more energy when it went down the longer ramp because it went twice the distance. So somehow it has twice the something. No, it's going to have exactly the same amount of something. All right, well, he screws up here and it falls off the end and he has to fix that. And so let's not bother with that part.
Go. Now it is losing some of its potential energy, gaining kinetic, losing energy.
So saying gaining kinetic is just silly. It's gaining momentum. It's not gaining anything called kinetic energy. It will not, after traveling this longer distance, have any more energy than it's going to have going the other way. All right, going left isn't going to be more energy than going right. It's just nonsense.
Really, because friction is in the system, and we hear sound, which costs the ball something. It cannot produce the acoustic energy for nothing.
There. So that's, yes, exactly. So that's all work done on the environment. Okay.
Now, what do some think? That coming down this long track, the ball down here will have enough velocity, enough kinetic energy of motion.
So again, he's saying kinetic energy of motion, and it will be illustrate again if he uses two different masses, that one of them is not going to have twice the energy. It's just not going to be true. It's going to go twice the speed and have half the mass.
To put it up over the track here.
I mean, obviously this is gravity, so it's not going to be twice the speed. So it's just going to have half the mass at the same speed, so it's going to have half the impact energy.
But that is not so. If the system were absolutely ideal, no friction at all, which is important.
So this has nothing to do with kinetic energy versus momentum. Energy and momentum. This is really not going to demonstrate anything, frankly, useful, related to the controversy.
Possible. The best the ball could ever do would be to go to the same height here. And since we are in a real world and friction plays a large role, the ball can never go as high on that end as I let it go from on this end. Watch it.
Yeah, so yes, as far as we have created, so yes, it's finding a frictionless, near frictionless, mechanism. Maybe they can do something in space. Who knows?
Oh, it did. I'm glad.
Okay, stupid. So yes, I had it too high. Blah blah blah. Oh, All right, sorry.
Energy of the system is spent in friction and in producing sound and in
did
vibration.
That part.
A very beautiful demonstration.
Oh, sorry.
A device which I
here it
call
goes back and
Experiments
forth.
Never Fail. I'm going to lower this a little. And now I hope that this end is the same height as that. Now watch it. Oh, that's it. And less, and less, and less, and less.
So what it is good for is also to see visually the distance difference. Because going up, it looks like a little tiny bit of distance it's losing. It's just little tiny bits of, it almost goes the same height. But on the other side, you can see really how much distance you're losing. And then with each roll, the first little bit, and then more, and the other way around. But anyway, all right. So all the rest of these experiments are absolutely useless. Blah, 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 blah. They don't really get to anything. He plays with some toys and all this kind of crap. What the hell did I just have? I don't know. It doesn't matter. Just get to the video. He doesn't really fire the gun. It just talks about recoil. Again, momentum. There's no evidence that the projectile can do more work. So again, the ballistic pendulum demonstrates that you can't collect any of the kinetic energy. It's uncollectible energy. How can you make an argument that this is about doing work when you can't make a device that can actually collect the energy of a bullet? You can't. All right, so here's the end part, is the part that's interesting. Yeah, okay, this is where he talks about the summing up.
Momentum, very important. Now, as one views the history of this subject, I invite you to study it yourself, because for 150 years, there was much dispute on the difference between mv and mv square.
All right, and so he's saying, yes, for 150 years, physicists argued this religious theory, and guess what? The Muslims won. That's, they beat Darwin. They beat the rational theory, got beaten by absolute mush because of silly experiments like pointy arrows versus dull arrows. Experiments so fucking stupid that no physicist should have been fooled. And all of this happened after Newton. Okay, so you had Newton, who was so good at, getting to the truth. And then all of a sudden, without Newton to organize the world, they all went batshit crazy and accepted absolute babbly nonsense as the truth. True, it's a true story. That's what happened. No good evidence. So they argued it for 150 years by arguing, you're a flat earther. That's what they basically just kept pointing their finger at each other, going flat earther, and very little substance in the arguments, unfortunately. But I can't find the arguments, in a sense, so there's no point in really arguing it, because there's no arguments to be found. I mean, there's some of the arguments are so convoluted, like you're on a boat and you walk 15 feet this way, and then then you're on a turntable that turns you to the opposite side, and then a bird shits on your head, and somehow in that story is proof of kinetic energy,
which was settled by a Frenchman named D'Alembert.
So it wasn't settled by, he just said, oh, it's just semantics, let's pretend there's no difference, and just pretend, it's okay, don't worry about it, don't pay any attention to it, it doesn't matter. When clearly they're different answers. So, believe whatever you want is just really stupid.
But who gave rise to the problem in the first place? A young Dutchman by the name of Christian Huygens.
Anyway, yeah, but it was Leibniz who pushed it, called it vis vis of the living force. He was really the motivator for the controversy. So we don't have any follow-up that I can find from Huygens making any arguments besides the one argument saying it happens, and then that's it. And then I don't see him doing any analysis anywhere else saying anything defending it. Nowhere does he say, yes, it takes 25 times the fuel to spin something 5 times as fast. Doesn't say that.
And I want to show you a picture of him as a little boy at the age of 11, an enchanting little rascal. And I shall have more to say about him sometime on a program on light, because he spent his youthful days throwing pebbles into...
So it's all, yes, Huygens was, responsible for some real wrong turns in physics. And so as much as, Huygens was a really great clock maker. So he did some really precision things with clocks, pendulums, all that stuff, figured out how to make military timepieces, that could tell time on the ocean and all that kind of crap. So did a lot of good things, but wave theory, bad idea.
The canals in his native Holland and watching the ever-growing circles of disturbance, and thus was led to the idea of the wave motion of light.
which is just crap. Doesn't happen, and it really doesn't work. Okay, if you really think about the two-source theory, it doesn't work because we know with the single slit you can make all kinds of pattern, and there's no way to make two waves pop out of a single slit. So why are you talking like this? Why do you believe this crap?
And here, finally, is a picture of him in his later days with his
Leibniz wig.
What shall we call it? Wig. Now, the idea of momentum must be clearly distinguished from the idea of energy.
Why? Why? So we know that Newton's third law only works, right, with momentum. So spaceship thrust, I have to calculate the momentum of the thrust. If I calculate the kinetic energy, it won't tell me how fast the rocket's going to go. If I calculate the momentum, I'll get the equal and opposite reaction, and it'll work. It'll tell me how much work the thrust will do. And if we're calling work moving the rocket, right? So that seems a pretty obvious definition of work, right? Moving the rocket from one place to another. Well, what will make the rocket move? The momentum of the thrust or the kinetic energy of the thrust? And the absolute fact is, it's the momentum. I can shoot the bullet out one side of the ship. I can shoot the recoiling gun out the other side of the ship. The bullet side doesn't create more force. There's no equal and opposite reaction to the 2,000 joules going one way and the 2 joules going the other way. It's the rocket sees 2 joules and 2 joules. It just sees the momentum. Those are absolute facts. And here you're arguing with me. You're not defending the truth. Instead, you're piling on your lies and distortions and nonsense.
And I thank you for your attention.
Oh, okay. I thought he did. Oh, yeah, he just drew the MV. Okay, so there wasn't much. All right. So just terrible crap. All right. So we'll do one more little segment, I guess, and then call it a video. All right. So I worked out what I would claim reason, momentum theory would say happens when you do these collision experiments using the same input energy, a one mass going, let's just say 100 velocity, just for the sake of simple mathematics. So it has 100 momentums, okay, coming in all the same. And in each circumstance, so if you hit the same object, same mass, 100% of the motion goes into the other object, and it moves at the same mv, same mass, moving the same velocity. And so then if we do a 1 to 2, now this experiment's been done a ton of times on the internet, okay, one mass into this 2 mass, okay, elastic. Now the problem is they always use a spring, okay, so springs, as I pointed out, are automatically going to lose some percentage of the energy because the spring is going to end up wobbling after it's done pushing apart the 2 objects. So you're guaranteed to have some losses, more substantial losses than a pure elastic. So instead of allowing 2 cars to hit 2 metal things into each other and bounce off, they always use rubber bands or springs or some other mechanism to make it super elastic. So even though it's a known fact that the metal cars will hit each other, the aluminum cars, and go ping, and it'd be very efficient, very elastic, they never do it that way. So in the one case where Professor Lewin did do it that way, in the sense that he had Velcro that didn't stick, it came out exactly like those numbers, except the direction of the one mass remained in the same direction. But at this, one at 16% of the velocity, okay, and the other side had the 83. It has 41 of velocity in a double mass. So the substantial 83% of the momentum is in the object leaving. So it's exactly the way it came out. But anyway, and then there's the Lewin's clay experiment where, yes, they get the 133 going this way, so 133% of the momentum and 33% going that way. Nonsense. Now the Dispar lab loony, okay, keeps saying he's done this experiment. He's done it 17 different ways, and proven, okay, that he made 150 go this way and 50 go that way. So you got a total of 200 momentums. You have an impact with 100 goes in the box, and you end up with 200 total momentums coming out of the box, presumably pushing on the outside of the box with 200 momentums. Nonsense, doesn't happen, but anyway, and so the real numbers are, you know, it's 1/4 of the velocity, 25 v. Okay, I guess I can point to things. So 25, all right, and 25 velocity on the other side. So the two will have the same velocity, but it's only 75% of the momentum and 25% of the momentum. And so then when they recollide, the 100 pops back out because the heavier object has the extra momentum, and it is able to convert it back into 100 out again. And that's how it oscillates back and forth. So it's not losing 100 momentums every time it collides. 100 momentums disappear, and then all of a sudden 100 momentums reappear, and then they disappear, and then they reappear, by their theory. All right, then, so when you go to a 4 mass, you get this interesting 50-50 thing, okay, but you're way down in the velocity. So it's all the way down to just 12.3, so whatever that is, 5%, 10%, no, 5%. It's only, no, the percentages are just such a pain in the ass. I mean, it's 1/10, so that's more like 1/9 of the velocity. All right, and the other side still has half the velocity. All right, so, and then see, these numbers always match the velocity numbers on this side. So whatever percentage of the momentum is the same as the percentage of the velocity, because it's the v is 100 in this case. So we're calling that 100%. So obviously that works out to make things simpler on this side. Well, anyway, so you get up to a 5 mass, and you're only going 5v now. So it's only, now it's down to 1/20th of the velocity. And then it's 2.6 with a 6 mass. And when you get to a 7 mass, then you finally have 0 motion. So that would be the interesting one to see, if it's actually true that all you have to do is be 7 times heavier, and now there's nothing. But clearly by their theory, so the big difference between momentum and their theory is all of these lines here, all right, stay gigantic. So, yeah, I don't even, do I even know how to draw that? I mean, I can't draw 133%, right? I mean, it's just, but anyway, so their idea is that the line is, you know, here is 200%. So 200% of the energy goes in here. So that's the only way I can draw it, is that I have to take this 83 and make almost twice the line. And so they're saying that this is 180%, and this 175%, and this 100, well, 150 is right here, the famous Dispar one. So their theory says, okay, that that's how it works. That somehow I make twice the momentum go into an object that doesn't move. That's their theory. That twice the momentum went into an object that doesn't move. It has, you know, a velocity, even though it's not moving. yeah, that's their theory. So anyway, I'm just saying that I've given you the rational view of it, and I say those numbers will be verified by any carefully done clinical experiments. And so that's what we really need to see, is we need to see somebody do the 4 and the 5 and the 6 mass and see what happens. See if they get this huge amount of momentum, because their theory says more and more momentum will go that way. So the more I increase the mass, the more I increase how much momentum is going to go that way until I get to 200%. Till I've made twice the momentum. I've put twice the momentum into the object. I've made free momentum. There's no other way to look at it. It's free momentum. And they say free momentum is a concept. You can make free momentum, and it doesn't mean that you have any more ability to do work. So even though you have twice the momentum, and momentum moves spaceships, by the way, even though you have twice the momentum, somehow you can't do twice the work. Obviously you can. Yeah, obviously you can. All right, so anyway, just for the sake of it, I think these are the right, I finally got it figured correctly. And so I think those are the accurate predictions, what will happen in the actual reality, and blah, 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 blah. And their silly theory will eventually be proven to be nonsense if they'll actually do these experiments. But Steve Mould won't do the simple experiments. Instead, he wastes time with fire hoses and why things wiggle and why things do this and why things... But no, the basic argument for which he just proselytized nonsense. He didn't produce any experimental evidence and just claims that somehow levers fail. That you can take a lever, you know, and you don't have to obey the law of the lever. You can put a 1.4 mass here, okay, and cause a 2 mass here to fly off at one velocity. So I basically just saying that somehow I don't need the same momentum to cause the same momentum. I don't need to have a balance on a lever. Of course you do, and of course if you were to obviously put 1.4 in with a 1 mass and have the same kinetic energy as the output, it won't work. It's not going to happen. You can't use 2/3 the momentum and make 100 momentums. You can't make free momentum. All right. So anyway, so till the next time and such and so forth and whatnot. Will ever... I mean, it's just sad and pitiful, you know, that here we are in a modern age. People have no respect for science, doing any arguing whatsoever. They won't tolerate it. I suppose I should read. I found some guy's little statement in one of those forums. And let's understand, every forum I went to, I got blocked because I argue physics, not anything else. I just made these arguments, and they say you just can't do it. We won't allow you to make arguments defending anything but our known science, because we know it. We haven't proven it, we don't have any evidence, but we know it. I mean, that is their attitude, and it's so anti-scientific, and it's just amazing that you all just fall in line and say, yes, count me in to, you know, the Trumpoplex, you know, the bullshit, the big lie, fake, phony, fraudy. It's disgusting. All right, so let me find that little bit, and I'll read a paragraph. All right, so this is one of the arrogant douchebags on what forum is. So this is Stack Exchange. So somebody just brings up the subject of, you know, what is it with these two formulas, blah, blah, blah. It doesn't make much sense. All right, and let's see. Oh, here it is. Okay, so he says, so he does a whole bunch of stuff, Ligarians and all kinds of other bullshit arguments that somehow this is really complicated. All right, anyway. On the whole, I found most of the above comments interesting and helpful. My thanks to their various authors. What a douche. Anyway, it's not useful in a discussion of this kind to make derogatory remarks. Now, just let's see how long it takes him to make a derogatory remark. Or slanderous generalizations like physicists are unwilling to admit something is fishy. So that's what somebody said. Physicists are unwilling to admit something is fishy. And that's, oh, you've gone way too far. How dare you? You're suggesting there's something, shenanigans? No, you can't say that. Apart from not being useful, this kind of sentiment, how else does he's supposed to express it? You know, you've had 350 years to compile some evidence. You don't have any, okay? You haven't crashed cars. You haven't done a damn thing to prove this stupid fucking theory. And how does somebody say that without offending you? Okay. Can only brand you as disaffectioned. Anyway, or possibly even loony. Okay. So he just called them loony, but that's constructive ad hominem bullshit, right? Oh, they're just such hypocrites. Let's see. Uninformed value judgments like energy. So this is another quote. Energy has a physical meaning. It exists in nature, but momentum is completely made up. So this is somebody actually making an argument in their defense, in a sense, and he doesn't even like that. I mean, obviously one of them is completely made up, right? I mean, the one that's completely made up is obviously the kinetic energy. We know that the one that worked in nature for hundreds and thousands of years is momentum. Again, the law of the lever was a statement about momentum made 2,000 years ago. I mean, it's pretty obvious it was just about mass and, the difference of being on the outside of the lever is the change in your velocity. So clearly it was making it clear, half the mass, twice the velocity. Anyway, are also not helpful. So anyway, they display ignorance and smug complacency in that ignorance. So that's okay to say too. Both energy and momentum are made up. So this guy's arguing that they're both made up, that we can't really understand how the universe works. There's no substance called energy, and energy doesn't be possessed by matter, in any way. It's just some sort of magical function. Things just magically go. Okay, there's no difference. The electrons and the protons are all the same inside of the wrench flying through space and the wrench sitting at home. Those two wrenches have exactly the same profile. They're identical in every single possible way. And it's just magic that makes the one of them keep moving. Yeah, sure it is. Oh, it's just so bad. They are elements of a mathematical model. So again, a model of what? Where's the mathematical modeling anywhere? You just put a square on a velocity for no good reason. There's no model. There's no explanation for why I would do that. Just like in electricity, there's no reason for me to square the voltage. Okay. That we have found successful. So found it successful in what way? You can't collect it with a ballistic pendulum. You can't make a rocket move with it. Where exactly is it a success? See, I keep asking for that too, and I don't see it. Where does it build a bridge? Where does it do anything ever? Where is this used ever successfully? Okay. Further, momentum is as real in nature as energy. So isn't that a silly statement? We know that one of them has to be wrong because they get different answers for the same question. This whole thing right here, very different answers. 0 and 200 are hugely different answers, right? How much does that 7 mass move? They say 200 momentum. Okay, the velocity is still going to be like 1.3 or something. It's going to be very slight, but anyway. They say it has the 200 in it. All right, it's a huge difference in the description of the reality. Okay, my theory says 16, their theory says 199. Okay, momentum versus kinetic energy. As you would find out if you would apply brakes on an icy road. So this braking on icy road thing, like this somehow proves anything? Of course it proves absolutely nothing. The conservation of momentum as you continue to move with uniform motion in a straight line is very real. So it obviously isn't very real, because obviously I can just keep banging these pendulums in and keep moving to convert all of the energy going this way. The 100, I can convert it into 300 momentums going that way, nothing going that way. Because it's in a pendulum, I'm going to get the energy back to hit again and again and again. It's just idiotic. As is the destruction of that momentum force. So somehow you can destroy momentum. So we continue moving in a uniform motion in a straight line is very real, as is the destruction of that momentum force when you hit a solid barrier. So he thinks you destroy momentum. You're just saying it right there. Somehow you're supposed to believe that when you hit something, you destroy the momentum. So when a bowling ball hits the pins, it's destroyed its momentum. It didn't give its momentum to the pins. No, its momentum was destroyed. I mean, it's just too fucking stupid. And it doesn't even make sense from, like I said, the Professor Lewin sleepless night argument of, when you hit a solid barrier, Professor Lewin tells you overtly that 200 momentums, twice your momentum, went into the wall. It wasn't destroyed. So he says, as is the destruction of that momentum force when you hit a solid barrier. No, the argument is it isn't destroyed at all. It goes into the wall, 200 goes into the wall, and you get your 100 back. I mean, that's the key experiment, right? Is this 1 to 6 thing. Because then you're going to get at 83. You're going to get a huge amount back to hit it again and again and again. All right, so too ridiculous. All right, so now that's enough of a video, I believe. So till the next time and such and so forth and whatnot. And it's all very depressing. And I hate existing on this planet among all you conniving, scheming, really belligerently ignorant, scummy assholes. Yeah, there's no other way to describe you all. I mean, you're defending nonsense. You have no evidence. Again, you can't link me to any credible evidence. Anything. Nothing even close. Again, I could play the Mythbusters video over and over again. And what do you have to compete with it? Oh, that's right. You haven't done a single experiment. You haven't anywhere ever experimentally tested this silly theory to see if it does 5 times the velocity, does 25 times the work. Yeah, nothing. No evidence whatsoever. You haven't crashed things into each other. You haven't done tug of wars. You haven't done anything to demonstrate the truth of this nonsense. And all you can muster is ridicule of me for bringing the subject up. Oh, how offensive is that? To challenge your really bad science. Somebody's challenging science you have no evidence supporting, and you feel offended and aggrieved. Fuck you.